So this is a very interesting question. So let's see what it says. Says the cylinder of radius r, which is 5 meter, rotates about the vertical axis. So let me draw a diagram. So the cylinder, the large cylinder perhaps, has a radius of 5 meter and it rotates around the vertical axis. And there's a girl. She stands inside the cylinder with her back touching inside of the wall of the cylinder. She is standing here, right? And then we start to rotate the cylinder. The floor is suddenly lowered, but the girl stays glued to the wall. So what happens? Now the cylinder is rotating with, let's say, angular velocity omega, okay? And the floor is removed, but we'll find that the girl is still sticking to the wall, okay? She does not fall down, okay? Does not fall down, okay? The coefficient of friction between the girl and the wall is mu, which is 0.6. So first thing first, we want to know why will the girl not fall, right? To answer that question, we need to first draw the free body diagram. So this is our girl. The first force will act with the weight, which is mg. If that was the only force acting, surely the girl will fall down after removing the floor, right? We remove the floor, but girl sticks to it. So there must be some friction force which is preventing it from falling, right? So that's going to be force of friction, which is preventing it to fall. And if that friction force is sufficiently large, right, the friction force less than or equal to the weight, the girl will possibly hold there, right? In case of static friction, this is going to be equal to, so friction force is equal to mg, the girl will fall. Now the friction force depends upon the normal reaction. The second force which we want to look at is the normal reaction from the wall, which is going to act leftwards like that, and the friction force is going to be equal to mu into n, right? Mu into n. So the friction force, the mu n, and that is going to be equal to mg. In that case, the girl will not fall, right? So there will be sufficient n provided for, so that when multiplied by mu, it has to be equal to mg to hold the girl from falling. Okay. Now determine the minimum number of revolutions per minute. So we are looking for the frequency per minute, so that the girl does not fall or does not slip down the wall. Now this n, because the cylinder is rotating like that, this is a centripetal acceleration, the centripetal force which is acting on the girl, making her move in a circle. Okay, so in this case, the normal reaction from the wall is our centripetal force. Okay, and that is making the girl go round in the circle. There has to be a centripetal force for any object to go around the circle. In this case, it is a normal reaction from the wall, right? So how much will the value of the centripetal force? FCP in this case is going to be m omega square r, or m v square by r. I'm going to proceed with omega because in that way be easier, right? Because the cylinder is rotating with, let's say, angular speed omega. Okay, so this FCP, which will be also equal to the normal reaction, which will be my normal reaction provided the wall is going to be m omega square r. So the friction force is going to be mu into m. So the friction force is going to be mu m omega square r, and that has to be equal to the weight, right, for the girl to hold. Okay, so mu n should be equal to the weight. Now m and m will go away, and we'll get omega square will be now equal to g divided by r mu. We can substitute our values to find at what rotation speed, this will happen. So omega square minimum will be required. Let's say g is 10 and r is 5 meters and mu is 0.6 meters. So that's going to be 10 divided by 10 divided by 3. That's going to be 3.33, and my omega is going to be root of 3.33. That will be 1.82 radians per second. Okay, so we got the omega, but the question is asking us to find the frequency. So there is a relationship between omega and frequency, right? What is that relationship? Omega is also equal to 2 pi. Okay, so now we can find the frequency which is required. So frequency is going to be omega by 2 pi. Omega is 1.82. So this is 2 into 3.14. The frequency now which is coming is 0.29 hertz, right? Or to 0.29 revolution per second. Okay, that's 0.29 rev per second. But in the question, we have to ask how many revolutions per minute. So we need to multiply it by 60. And when we do that, we are going to get roughly 17.4 rev per second. So we must rotate the cylinder with 18 revolution per minute, 18 revolution per minute, and that will be our answer. Okay, and if we are going to rotate that cylinder with 18 rev per minute, we'll find that we have sufficient normal reaction provided, and that normal reaction will provide the sufficient friction force to hold the girl right in the air.